Microchip factories today run on AI and robotics, with smart systems managing power, air, water, and chemicals while predicting issues and optimizing every step. With 1,000+ precise stages, machine learning keeps production smooth, and autonomous robots handle materials to cut down delays and contamination. Micron just launched its 1-gamma DRAM and teamed up with Samsung for AI-powered devices. But inside the factory, it's robots doing the real magic. From wafer inspection to chip cutting and packaging, AI keeps everything sharp. And if the robots ever do take a break, it's probably to fine-tune their own algorithms. This isn't just a factory, it's a living thinking system, where AI and automation work in perfect harmony to produce the brains of modern electronics. At the center is the Factory Operations Center, nicknamed the Starship. And rightly so. It's the command hub, where AI controls everything: power, water, air quality, and chemical flows. One misstep in this 1,000-step process, and production grinds to a halt. That's why machine learning algorithms monitor in real time, predict issues, and adjust operations before anyone even knows something's wrong. Meanwhile, overhead, robotic buggies zip through the air, delivering wafers across the clean room with pinpoint precision. They travel over 400,000 kilometers every day. Yes, around the Earth 10 times. And they never ask for a coffee break. Human hands stay out of the way. AI coordinates machines, maximizes efficiency, and reduces the risk of contamination. What used to take an entire team now takes one technician and a wall of glowing dashboards. But intelligence isn't just for speed. It's for sustainability too. The factory recycles nearly 80% of its water, transforms waste chemicals back into usable materials, and even grows vertical gardens to lower energy use. In this mega factory, AI doesn't just assist, it leads. And in doing so, it's quietly building the future, one microscopic chip at a time. It all begins with a sliver of silicon, sliced from a purified ingot, then polished until it's smoother than glass. These wafers are the blank canvas. Before they ever see a circuit, AI inspects every surface for microscopic imperfections. Only the flawless move forward, ready to become the foundation of billions of transistors. Above the factory floor, AI-guided buggies race along overhead rails, swiftly delivering wafer pods like a sci-fi subway for silicon. The fewer humans involved, the better. Why? Because even a single dust particle can ruin a chip. So robots handle everything: wafer loading, unloading, and delivery. AI reduces human contact not just for efficiency, but to maintain the ultra-clean environment these chips demand. Inside the photolithography chamber, AI delivers nanometer-level precision. Each wafer must align perfectly as ultraviolet light prints the circuitry. If anything's off, AI catches and corrects it instantly, faster and more accurately than any human could. Elsewhere, robotic systems manage air purity, pressure, and temperature. The clean room is 100 times more sterile than a hospital. And yes, there are even AI-powered air showers. Think airport security, but smarter and less likely to misplace your shoes. Across the factory, AI synchronizes thousands of machines, making real-time decisions, predicting faults, and optimizing resources. With over 1,000 precise steps, only AI and robotics can match the speed, scale, and accuracy required. They don't sleep, they don't make excuses, they just build the future, one wafer at a time. Once the wafer's long journey through fabrication ends, it enters its final and arguably most delicate stage: testing and assembly. And once again, AI and robotics take control. First up, inspection. Not by human eyes, but AI-powered microscopes, scanning each chip for the slightest defect. These systems process up to 30 petabytes of data a day, more than you'll stream in a lifetime of Netflix binges. Machine learning models sift through this ocean of information, catching errors, predicting failures, and adjusting the process in real time. If one chip's off, AI recalibrates the system before the next even arrives. Then comes the slicing. Robotic arms wielding diamond-tipped blades cut the wafer into hundreds of tiny chips. Precision here isn't optional, off by a few microns. and you've just made a shiny, useless square. Each chip is gently lifted and placed onto a circuit board. AI-guided wire bonding machines thread fine gold wires, thinner than a human hair, to connect them. It's like threading a needle blindfolded, millions of times without a single miss. Next, encapsulation. Robots seal the chips in tough black casings. These aren't just for looks. They protect against moisture, heat, and the rough realities of the outside world. Through it all, human hands step back. Less contact means less contamination, and smarter machines mean better results. This isn't just automation anymore. It's a thinking, adaptive production line, where AI calls the shots and robots carry them out with perfection. In the end, each chip rolls off the line, tested, tagged, and ready to power the devices that run our world. Smartphones, servers, even spacecraft, built by invisible teams of AI and machines, quietly engineering the future. In today's megafabs, sustainability isn't just a bonus, it's part of the core design. And behind that shift, AI, running things quietly, efficiently, and without missing a beat. Start with resource flow. These factories consume massive amounts of water and chemicals, but AI makes sure not a drop is wasted. Sensors monitor purity, pressure, and flow in real time. The system responds instantly, diverting clean water, recycling used solvents. No guesswork, just precision. Energy? Same story. AI balances usage across the facility, predicting spikes, trimming waste. Cooling isn't just on or off. It adapts to heat levels, airflow, and even machine rhythms. Every watt counts. Inside the clean rooms, AI keeps the environment stable. Airflow, humidity, temperature, all adjusted in real time. Think of it as life support for machines. Outside, green walls aren't just decoration. AI calculates where they should go, how they reduce heat, and when to water them. It's not about speed anymore. It's about smart. This isn't just automation, it's intelligence built into every layer. Cleaner, leaner, smarter. And the robots? Still working non-stop. Only now, they're a little greener too. The future of semiconductor manufacturing isn't just fast, it's fully autonomous. And at the center of it all? AI and robotics, evolving into something smarter than ever before. Chip design itself is being transformed. AI now assists engineers in mapping out transistor layouts, optimizing architecture not just for function, but for efficiency. It's like having a co-pilot who never sleeps, constantly testing what-if scenarios and tweaking for peak performance before a single wafer is made. On the production floor, the goal isn't just automation, it's autonomy. Machines now make real-time decisions, with AI predicting chip behavior at the nanometer scale and adjusting processes on the fly. Human hands step back, not for lack of skill, but because robotic arms offer sub-micron precision from start to finish, turning wafers into finished chips with barely a whisper of human touch. The next-gen factory is learning, adapting, even self-correcting. A closed loop where AI monitors, analyzes, and improves continuously. It's not just the future of chip making, it's the blueprint for how machines will one day build everything. Thanks for diving deep into the heart of microchips mega factories with us, where AI and robotics don't just assist, they run the show. From wafer to chip, from dust-free halls to self-correcting workflows, this is the future of tech being built in real time. But here's a thought. If AI can already design chips and run entire factories, what role will humans play in the factories of tomorrow? Let us know what you think in the comments. And if you found this fascinating, stick around. Our next video explores the wild world of transistor physics and the race to the 1 nanometer frontier. You don't want to miss it. Hit like, subscribe, and share this with someone who still thinks chips come from a bag, not a fab.